Okay, good afternoon, everybody. You're all very welcome to this REDAWN webinar. I hope that you can hear me okay. My name is Ingus McNabole. I'm chairing this session this afternoon on micro hydropower in water networks, which will give you an idea of some of the technical, institutional, and also some policy case studies. It mentions there in the title that this is pre-recorded. Well, it is partially pre-recorded, so I can assure you that I'm speaking to you as live as the satellites can make it right now, and that the speakers are also here to answer questions afterwards. So just their talks are pre-recorded to try and avoid technical problems. So to begin with, I'm just going to give you a very short introduction to what the REDAWN project is, and then we will kick off with we have two presentations of about 20 minutes each, and we'll take then the last 10 minutes or 15 minutes to answer your questions with the speakers. Okay, so next slide, please, Charlotte. So the REDAWN project is so as you can see on the screen here, hopefully a 3-year research project which has been funded by the Interreg Atlantic Area Programme through the European Regional Development Fund. And this is a project focused on hydropower in various kinds of water networks. So REDAWN is an acronym for reducing energy dependency in Atlantic area water networks is what REDAWN is about. And you can find out more on the website there, redawn.eu. So next slide, please, Charlotte. So an overview of the project is here, and I guess today the two talks are on aspects of what the work that was to be involved. So the aim of the project is to foster a greater adoption of hydropower technology in water pipe systems in the Atlantic area, which is, let's say, our funding area remit, and that is examined from an institutional, social, and technological perspectives. So we not only consider the technology from the engineering kind of perspective, but also the non-technical challenges, which in many ways are greater. So the project includes an assessment of how much energy is available in these water networks across sort of 5 European countries: Ireland, the UK, France, Spain, and Portugal, and completes an assessment of how much energy is available, and really those assessments are complete at this point. So the project is getting close to its end, and there's a tremendous amount of energy available in a very large number of places. Now our webinar today doesn't actually go into the resource assessment part. We're presenting a series of webinars about the different aspects. So another one, which I'll mention later, touches on that. So from assessing the amount of energy available across these European countries, we were also able to conduct an assessment of the economic impact of exploiting that and the environmental impact of it, to do work on developing tools and design guidance for implementing these hydropower systems in different types of water networks. So one of the unique things about the REDAWN project was it looked, there's been lots of work on hydropower in drinking water networks, recently and in the past. But so the REDAWN project looks quite in depth in irrigation networks, in wastewater, and also in process industry sectors, by which we mean industrial facilities that use a lot of water, like food production, mining, and things like that. So we have touched on all those. In today's talks, we're going to hear a little bit about the third last bullet point, which is about the policy and institutional supports available to help or hinder the implementation of these. The project also looks at the social impacts, and then we're focused on spreading the message about how this energy is available and how it can be utilized. So next slide, please, Charlotte. A key part then of this communication is also physically demonstrating this hydropower in practice, which at the beginning of the project we set out to do in a number of places. So the diagram here kind of illustrates the 4 sectors in which we were working on: water supply, wastewater, process industry, and irrigation. And then within that, there are different settings within each one. So our first talk today, we'll hear a little bit about our French pilot plants, which were done in conjunction with a French water company called SMPGA, up at the top of the slide, which in fact there are two hydropower plants there. We also have completed one in Spain, in the south of Spain, in a pressurized irrigation network with one of our partners, for Agua, and we have plans for one at a paper production facility in Portugal. So I think next slide bring me to the introduction of our two speakers today. So our first speaker is Yves Cabaret, who's the Deputy Director of SMPGA. And SMPGA have been centrally involved in REDAWN in the demonstration of hydropower energy recovery in a network in northern France, in Normandy. And so Yves will talk about his experience of hydropower from the point of view of a water utility in the French setting. And following that, we will also have a talk from Dawn Murphy, who's a Senior Project Manager at Action Renewables, based in Northern Ireland. So Action Renewables are the leaders of this project, and Dawn will mention a little bit about the barriers and opportunities, so that kind of policy context. So the EU institutional policy and social context for hydropower exploitation. So I hope that you will enjoy both of those talks, and I'm going to switch off my camera here and encourage everybody to turn off their mics if they haven't already done it, and we'll first listen to Yves Cabaret.
Hello, nice to meet you. So today we will speak about REDAWN, and REDAWN, but in France, because we will focus ourselves about energy recovery in drinking water network and learn some elements from the French demonstration sites. Some few words about me. I'm Yves Cabaret, I'm Director of SMPGA. I'm an engineer specialized in water technologies since 2012, with focus on chemistry and water treatment. I work in SEDIF water network. SEDIF is a big public structure near Paris area, about the patrimony renewal of the pipe. And then I moved in 2015 in Normandy, in SMPGA, to handle a big project of investment of 32 million euro to secure the water distribution system. I entered in 2017 in the REDAWN project because we are a French structure, and it was very interesting for our structure to propose our network for experimentation about energy production. So I apologize myself for my English, but I will try to do my best. Some contextual elements. You know, ecological transition impacts on water industry with a large electric consumer. So you have two possibilities. Less consumption, so you have to work about energy performance optimization, or better consumption. You need closer energy and greener energy. So to have closer energy, you have to limit the energy transportation, and to have greener, you have to search new possibility to produce energy. And do you know which are the main green energy production possibility in water system? You have 4 water systems: industry water or irrigation, drinking water, wastewater, or rainwater. In industry irrigation, you have flow and you have pressure. In drinking water, you have the same flow and pressure. In wastewater, you have heat, gas, flow, and pressure in some conditions, especially in plants, for example. And for the rainwater, you have the flow. About SMPGA, we are a public structure, very new. She was founded in 2014 to secure the territory in water system. And we are in the north of France, in the south of Normandy. And SMPGA take advantage of the REDAWN project to improve the water network with technical contribution from project experts and European financial support. So it was an opportunity for SMPGA to come in this project, come in the last one, to have this network and this innovation. It is also a strategy for designing the future. You know, if the principle of micro hydroelectricity is working, you have a very great potential for the city of Trinidad. Because in an urban zone, the water network system is very highly developed. So for us, it is an innovation totally adapted to public structure. Because we are a buyer, and it is very easy for us to create a new market. If the buyer needs something, then you have more proposition. Our decisions are political, and they are also linked to the city plan. We have connection with the whole politics. We can also present a global project where the production of energy is not always for ourselves, for water distribution, but can contribute to public development projects. Some example, you can use energy for filling charge point, metrology, security areas, lighting system, and you can also check the best possibilities and alternatives to find a local source instead of the traditional grid connection. And also our institutional structure is based on a commitment to understand, act, and influence future energy management possibility, because we are connected to the political institutions. So let me present you the first example, the first pilot plant we built with the REDAWN project. It is the pump as turbine, PAT. So you use a pump, not in the traditional mode, but you use it in the reverse mode with a generator. And we put directly the electricity in the plant. So main issue of this installation, you have first of all to secure the network if you use the PAT, because the PAT dissipates pressure in pressure network, but the efficiency is linked to the flow and pressure condition. And in a network, you can have variability. So you cannot use a PAT instead of a pressure stabilization system. It is you need your pressure stabilization system to secure if your PAT have a problem and don't make his work good. You have also the pressure stabilization system, but you put your PAT just before. You need also to protect the electricity production, and if you have a problem, you generate electricity, so you need a convector to burn this excess of energy to secure your installation and don't make fire. Some words about the dimension. You need to begin your installation to have some data, and these data are very, very easy to know. You need the flow and the pressure before and after the site where you want to install your plant, your pilot plant. And you need about a half bar of pressure drop minimum for PAT. And then you need to elevate to and electric losses, because the total efficiency is different. It's not just hydraulic. You have also loss in the electrical part. For example, you can design your PRT, you can find with some constructor the curves to find the best point, and then you can have a very high hydraulic possibility and hydraulic the good product with the condition of your sites. But the more you can have is about 80% of hydraulic possibility. And then you put a generator to produce energy. Then you have electrical authorities, and then the inverter, and then at least you have your network connection point. So with a beginning of 84% of efficiency, you go about 70% efficiency, and these are the true value we measure in our installation. And the last difficulty is, you know, it's new project, so it's not easy to find a firm which can monitoring this whole installation, the electrical part, the hydraulic part, and you have to search the good partner to do it. And then the last issue is about the data accessibility. When you have an innovation, it is very important to monitoring it and to have data to know what's happening in this installation. So you have to find and to know what you want to do. If you want the data in your system, or you want to have this data on web, so you have to think about it before. Here you can find the installation. So it is in the inlet of the drinking water treatment plant, and it is an easy point because the plant is fed by a tank, and so you have a stabilized pressure drop before entering into the plant, and we have separated the installation because this is the normal way, and you can use to close and to go to this way and then to generate energy. We do it at the end of 2019 with Veolia. Veolia makes the installation, and we also look expertise from Spain with a power turbine, because in Spain we have lots of this small firm, because they are linked also to the solar technology. We have a water flow stabilized about 314 quadrant meter per hour, and pressure drop about just 1 bar. So we produce hydraulic energy about 9 kilowatts. We have a generator voltage about 268 volts and an intensity about 14 ampere. And then the real production is 6 kilowatts. So it is not so much, but it is also high, about 3% of the global consumption of the plant, and produce for free and direct green energy. For example, 6 kilowatts per hour, it is about 7 houses of consumption. So it's not bad, and we just have a pressure drop about 1 bar. So you can find, if you have small hill, if your water comes from mountain, you can have very high pressure drop, and then more possibilities of production. And it is very a good example, because we use the energy directly for us to reduce the own consumption. Let me present you a second example, very different because it's not a PRT, it's not a pump in the reverse mode. We use a small turbine which don't need pressure drop, but just flow. Here you can find the product. And we make this installation with STGS, it's a small structure, with handle or network for us, handle and water. And we use the technical expertise from BMAT in partnership with Safe Innovation, which designed this project. We have a very low flow, about 15 cubic meter per hour, and we try to extend the sector to find the best productivity of the product, and a very low pressure drop. So here the project is not to produce a lot of energy. It is to present the possibility of find energy in the ground, in the network, in very easy point, because this flow and this pressure drop, you can find it in your network everywhere. And so we use it to feed a bank where you can find two USB ports for the school where you can wait and charge your phone. So it is green energy for the public design. You can also use it for metrology, and it is very easy to find a point. So we do it to make also communication for the public and for municipality to present how there is you have energy on the ground, you can use it, you can think different to design the public space. And to end my presentation, we have other example in France. For example, in Annonay, we were visiting this installation. It is installation with the micro hydro from Hydrowatt and Pont-à-Mousson. And here they have a very high pressure drop and a big flow of 300 cubic meter per hour, and they have a big production. In this example, it is very interesting because they have directly from the nature, the water comes directly from the nature, and so in France you can sell the energy and use it in the same way. And you have also other PRT, and we will try SMPGA to visit it to understand, have a better understanding of the possibility. To conclude, some obstacles of microhydro in France can be different in the other country, but you know, and we have a huge organization, Enedis, has the monopoly in the total French area, and there is no buying obligation with bonified price to buy green energy generated by water if it has been pumped once. So you can do it if it's come from the nature, but if you pump one time, you cannot sell it to the grid. For example, in Normandy, it's not possible because we take the water in the river, so we need to pump one time. But if you are going to the mountain, then you have water from the hill, and you can sell it and buy it in the same place and make financial bonification. So we try to have a low evolution because it's very interesting to move this restriction because to motivate the industrial world to do something about micro hydro. And it restricts the potential of synthetic energy. We have also in France the lot of paper to do to have this connection to the electrical grid when it's possible. And it is long, it is complicated, and so many firms don't want to do it because it's too complicated. And also the last one is an obstacle, but it's normal because you have new products, new innovation, so the price is higher than knowing installation. But there is an interesting possibility. You have a big potential for auto consumption, because in France you cannot sell it, so but you can use it for yourself. And when you are a public structure and you can also present it to public structure, you have also the possibility of sharing energy to design the public space. Because if you are near to the production, it is better for the environment. And you can use it also to charge battery system, to have better measurement, installation, and more data communication. You can propose it to the municipality instead of a classical connection. So there is a lot of possibilities. It is very an interesting thing to use for the future. So if you have some questions, you can do it. Our partnership, we are about 10 in the whole Atlantic area. And here is my contact for the REDAWN project. And if you want to contact me, you can send me an email or by phone. It's not a problem. So, bye-bye. Thank you.
Okay, thank you very much for that presentation from Yves. So I hope you found that useful and interesting. And if you have any questions, please hold them then till the end of the session. So we will deal with presentation or questions for both presenters at the end. So up next we have Dawn Murphy from Action Renewables to talk us about the policy context. So Charlotte, if you can.
Good afternoon, my name is Dawn Murphy and I work for Action Renewables. We are the lead partner of the REDAWN project and I'm leading work package 8 of the project, which is titled Policy and Social Impacts. As we've heard from the other speakers, the REDAWN project proposes to promote and exploit a technical solution to small-scale micro hydropower, which I'll refer to as MHP. However, without appropriately addressing the non-technical challenges, this technology will not realise its full potential in the region. So some examples of the non-technical barriers are shown on your screen there. Poor economic incentives, for example, a diverse water governance policy, a lack of support and poor management structures in some organisations to support water innovation. And so the aim of Work Package 8 is to enable a more rapid uptake of microhydro energy recovery through informing the development of supporting institutional, economic and water governance policies. So we're developing a governance framework to improve the design of related policies, best practice organisation management models in the 4 water network sectors, and assessment of the impact of social factors such as the cost of water for consumers, the cost of water on the environment and corporate social responsibility. And finally, best practice economic policy, so addressing energy cost, carbon cost, taxation and incentives. Today, I will summarise some of the work carried out in relation to benchmarking institutional structures and practices. This has been done firstly by researching a number of case studies of microhydro of various types throughout the Atlantic area, one of which is you can see from the photographs on the slide. This is our pilot micro hydro installation in Palma del Rio in Spain. We have also carried out focus groups and polling sessions at water industry events to find out the issues, the barriers and the perceptions of microhydro. Finally, we've carried out interviews with policymakers and water industry professionals across the Atlantic area. So far, we've gathered 10 case studies, and these include 2 of the pilot sites, which have already been installed. We have 3 case study sites in the UK, 1 in Ireland, 3 in Spain, 2 in France, and 1 in Portugal. And the second will be completed when the Portugal pilot is installed, which has been delayed due to COVID-19. So what did we want to know? Well, each case study involved research and interviews with professionals who were involved in the project to build up a picture. So firstly, the institutional framework in which the project was completed. Secondly, the drivers or the determining factors behind each project. The business plan and financial benefits involved for any of the organisations involved. The non-monetary benefits, for example, CO2 savings, knowledge transfer, any barriers that were encountered, such as administrative or technical barriers, and whether any form of post-project evaluation was completed. And if so, what were the conclusions of this evaluation and how would these inform any future microhydro installations? And what did we find? Well, there were various key insights emerging from each region. I've summarised a few examples of these for Ireland, Spain and France in the next few slides. So the key insights came from the institutional supports and practices which emerged from how each case study site was planned, managed and implemented. So these observations are in relation to one case study in County Wicklow in Ireland, which was a 70 kilowatt Francis turbine installed by Irish Water at a reservoir, which you can see on your screen. In this case study, it was clear that the personal enthusiasm of the lead project engineer had a significant impact on the progress, the initiation and the progress of such an innovative idea. However, lack of organisational commitment was also seen to act as somewhat of a barrier to the success of an MHP project. Unexpected technical issues can increase costs significantly and should be mitigated against at an early stage. Administrative processes and licence applications can be complex to navigate, especially if the team has little prior experience in this, which is what happened in this case. Grid connection costs can be prohibitive for larger installations and subsequently can curtail the optimum size for the installation. And engaging with electricity suppliers at an early stage is important to set up power purchase agreements. In relation to the Spanish case studies, the observations shown on the slide relate to 3 case studies, 2 of which were in the irrigation networks in Alicante and Palma del Rio, a 32 kilowatt and a 4 kilowatt turbine respectively, and one was a 92 kilowatt turbine in a drinking water supply network in northern Spain. So the barriers here included changes to the Spanish regulatory framework from a feed-in tariff to an auction system, which affected the economic feasibility of one plant, and also changes to the regulation of self-consumption, which also caused delays. Also changes to administration processes in the regional environmental ministry led to a licence application having to be repeated for one plant. Grid connection for one plant took quite a long time, a year and a half, and it was noted that the same grid connection processes were in place for small generators as for large generators. So that can cause problems for a small organisation with few staff. Demonstration was useful from the perspective of the manufacturer and installer. So validating the technology or having demonstration sites was considered important, for example, promoting to more irrigation and water companies. Determining factors included reducing running costs of a water treatment plant, especially if it was located next to the microhydro, as well as reducing fossil fuel dependency, for example, in rural areas. No administrative barriers were noted when installing when existing infrastructure was in place, due to the fact that there was an existing proposal, and also when installing off-grid. And effective collaboration between the public and private entities proved to work well, as both brought expertise. So the organisations all felt that a joint approach worked well. So in France, the observations are based on two case studies, one a 26 kilowatt turbine in Annonay near Lyon, and the second is the REDAWN pilot plant in Normandy. So the demonstration aspect again was found to be important to educate and inform industry professionals, for example, the water providers. Both water companies had a strong interest in innovation, which was a key factor in the decision to innovate in this way and to invest in microhydro. The water company in Annonay was part of a positive energy territory, and so therefore contributed to the Annonay Urban District Climate Plan. Private-public partnerships, where the installation or engineering company or manufacturer provide finance, seem to be an effective option for water companies at this fairly early stage in development of MHP, as it removes the risk and it also provides the water company with valuable experience. It was evident that the installations in France may not have gone ahead without this private funding. It also contributes to the public image of the water company, and potability accreditation for the Annonay example was found to cause a delay, but that's mainly because this was the first type of this installation in France. This was not a pump as turbine or PAT, it was an axial turbine, and therefore a PAT would have involved a more straightforward process. And finally, the grid connection feasibility study caused a delay in the Annonay example. The costs of the connection are provided to the applicant, however these are non-negotiable by the grid operator and could therefore impact on the economic feasibility of a microhydro turbine. So the second area I'll cover is the polling and focus groups that we've undertaken. We've carried out a polling session at the Water Efficiency Network conference in Aveiro, Portugal, and also at an event in the UK. And there was a mix of water industry professionals, government, public agencies, technical engineering, environmental science, and water professionals. So I'll show some examples of the polling questions in the next few slides and the results. And firstly, just a very general question, is there a general lack of awareness of microhydro as a renewable energy source? And as you can see, there's a very obvious yes to this answer among the industry professionals. This question asks which of the following institutional factors are crucial for the uptake of MHPs. So the options were public trust in water companies, policy or regulatory requirements, shared service delivery benefits with customers, financial or warranty incentives to reduce cost risks, and community-led innovation, especially in rural areas. So the most common response was policy or regulatory requirement, and also financial incentives to reduce cost risks. This question asks which top 3 technical factors affect your uptake of MHP. The technology is easier to deploy and install, performance reliability, higher energy yields, lower costs, available demonstrations, and ease of access to technical expertise. So the most important factor for the Portuguese audience was making the technology easier to deploy and install, suggesting that perhaps there are more complex issues in the water networks in Portugal. The second most important technical factor was having lower costs. The main drivers or determining factors to installing MHP were ranked by the audiences. So the cost of energy was the most important to the Portuguese audience, and financial incentives most important to the UK audience. So the financial aspect was key for both. And finally, the top barriers to the uptake of MHP in the water sector. Both infrastructure barriers and economic barriers were high in both regions. However, the UK audience voted environmental issues as one of the top 3 barriers. So these are just some examples of the results obtained, and we have similar data that we've obtained from online surveys that we've sent to various water organisations and industry professionals. So all of these will be combined into our final reports. The last topic I'll cover is the interviews with policymakers and industry practitioners. A series of interviews have been carried out with practitioners involved in the water industry in all of the Atlantic area regions involved in the project. And these interviewees included both public and private water companies, regulators, municipalities, engineering companies, community water scheme managers, as well as plant owners and irrigation companies, irrigation organisations. And the purpose of these was to gather the viewpoints and the experience of these professionals in relation to the questions shown on your screen there. So, for example, what structures are involved in the organisation for water innovation? What is the decision-making process for new equipment, for example, such as microhydro equipment? Is there a specific policy in place for microhydro or for renewable energy in general? We wanted to gain insight into the perception of using microhydro and also to find out what the experts feel are the barriers, which would help us build recommendations. So I've shown on the screen one of the regions, Ireland, as an example, where 3 interviews were carried out with the utility regulator and also with Irish Water, the company's only water provider, and with the Federation of Group Water Schemes. So just to give some context, 20% of the population in Ireland is served by small cooperative group water schemes, generally in rural areas outside the centralised public mains system. So from interviews with these key organisations in Ireland, there appears to be a general openness to renewable energy. However, there was no specific reference to microhydro, and it would be fair to say that any policy or objective or target in relation to microhydro would be in its infancy. So what you can see on screen are some of the main priorities of these 3 stakeholder organisations. So firstly, ensuring water quality compliance and providing reliable water supply, which is obviously their main purpose. Ensuring efficiency in the overall delivery of water services was one of their key priorities. leak detection, management and improvement programs, and also PV installation was a priority to increase the renewable energy generated and reduce operational costs. Other renewables are also considered, however, there must be a return on investment for the renewables. Energy efficiency is another key area for focus for Irish Water and the group water schemes. So, as I said, we have carried out several other interviews in each region, and the views and evidence that we've gathered in this research will complement the case study research in our final reports. So, to conclude, some of our other research in Work Package 8, which we don't have time to share with you today, relates to economic factors and social impacts. We're investigating the economic factors which influence the uptake of microhydro, such as the varying price of energy across the Atlantic area, the financial incentives, and the cost of the turbine technology itself. Our final policy framework manual will assess these factors for the production of policy recommendations to ensure that we have the maximum uptake of the technology in the future. And lastly, we have looked at social impacts of microhydro through a measurement tool called a social return on investment. This tool enables us to capture the value of a range of outcomes. It helps us to understand and quantify the social, environmental and economic value that is being created by the MHP plants, and gives us a ratio of how much social value is created for every €1 invested. So we've completed this for one of the pilots, and this will be done for the other 2 pilot sites in the coming months. And these results will be available in our policy framework manual later in the year as well. So that's all from me. I hope you found the overview of this work package interesting, and thank you again for your interest today.
Hey, thanks. Thanks very much, Dawn. Another interesting talk there, giving a different perspective. So as we have about 12 minutes then for questions and answers, and so if anyone has anything they wish to put to the speakers, now's the opportunity to either unmute yourself and ask it, or you can type also in the comments. So if you want to ask it in person, maybe you can use the raise your hand function. So while we're waiting for somebody to gather the bravery or type out their long answer, I had one for Dawn myself while I was listening to that. If you don't mind, Dawn.
Yes. Yep, I'm here.
So I was just listening to the different barriers across the different countries that you were mentioning in the first half of your talk there. I was wondering,
Yes.
Was there anything kind of cross-cutting in the European context that seemed to be the major issue everywhere, or was it quite diverse?
Well, I think because there was the case studies are so different, they all had their own unique barriers. You know, for example, the Ireland, the Vartree one there, on the slide, you know, they had a lot of unexpected issues, technical issues with, you know, aging pipework that, you know, hadn't been uncovered, hadn't been expected. But generally, I think the main issue was in the administration side of things. So, well, in terms of applying for or getting the feasibility of grid connection, that seemed to be a process that in most of the regions it does seem to take a long time. I know in particular one of the Spanish case studies, it was 1.5 years to get grid connected, and I know that's quite common here in Ireland as well, in Northern Ireland. So I think that's probably one of the main barriers, as well as just general administrative, applications, regulatory approvals. So I think those are the most common ones.
Okay, thanks very much. So we have a couple of questions in relation to Eve's presentation. So one is from Helena. It's asking an interesting question about how the users are, or the public are, accepting the solutions. So this is probably about the case of the very small hydropower plant that was installed beside a bus stop to power a very interesting, call it a Pico application, to power a phone charger and so on, and really for outreach purposes. So we're having a slight issue with Eve's connection, but Astrid is also working in SMPGAs here, and she is typing the answer at the minute. So I'll one second. So I was waiting for the answer to appear there, and these, excuse me, pop-ups keep popping in the way. So Astrid has replied that the bus stop has a good acceptance from the public. A short answer to your question, Helena. You also had another part to the question was, do you have any feedback from them? Was that about the same thing? Yeah. Okay. All right. So Terry Waugh has a question about Eve on the Eve's line with Helena's question. How has the industry viewed the installation, and has there been much interest from the industry? So this would be the water industry and the main installation at the plant. And again, Astrid is going to type the answer for us here. Okay. Okay, so again, for the water treatment plant, the industry think that it's a good solution. Sorry for the slight delay in the answers here. We guess we have to take into account the translation of things from French to English and so on, which is happening in the background. Okay. So I'm just going to scroll up here through some of the other questions in case I had missed one. So we dealt with Terry and Helena. Dawn has a question about if any other companies visited the French pilot plant. And yes, we have had visits from Veolia, Suez, and STGS. And I guess I've been interested in the cost of the energy saved. Okay, yeah, STGS I wasn't familiar with either, is a local water utility. Okay, another good question from Dawn. So will SMPGA consider installing this turbine at any other places in their network? Okay, so there you have the answer. Yes, we're working on it at the Avranches water treatment plant, which is a town in the locality of SMPGA in Normandy. Okay. So there's a question there for you, Dawn. I think can you take that? The barriers are solved, Dawn. Do you think that these solutions will be more spread over other countries?
Yeah, that's a good question. That would be the aim, I suppose, of the project, is to try and raise the issues of the administrative barriers, and where these projects have gone ahead and they've been successful and they've run relatively smoothly. We can identify the enablers, or the reasons why they've gone ahead without any issues, and hold that up as good practice, and comparing those with the other regions to showcase how these systems can be installed without major problems or delays. So that's that is the ultimate goal, I suppose, of the project. So hopefully we can showcase those good examples.
Right. So we have another couple of questions now. While you were answering, thanks for that answer, Dawn. So one from Paul Bond is: has the technology been used in new developments such as tall office buildings with foul or grey water, potable water? I guess I'll try and answer that myself. With tall office buildings, I haven't come across microhydro being used in that. I guess it would the building would want to be very tall for the power there to be a useful amount, for it to be bigger than the pico scale, because the number of people in a building and the flow that they would generate would be quite small. Whereas, let's say the pilot plant in France that we heard about today was eventually around 6 kilowatts, but that is on the basis of the flow from an entire small town. So when you go down to the scale of a building, then the amount of power available is probably not going to be so much, unless the building is very tall, maybe in a skyscraper application, which we don't really have in the area we're looking at in Europe. Okay, Helene, we're sort of running close on the time. Helene has put in another one there, I think as a kind of an answer to the question I was answering as well. I'm going to just, you can keep putting in the questions if you like, but I'm going to ask Charlotte to go forward, because there was, in the presentation, there were a few things I wanted to mention before we close. So yes, so which is the next webinar. So at the beginning, I mentioned some of the things that the project looks at, and so here we had an example of the pilot plant in France, and we had an example of the policy and non-technical issues. Our next webinar is on the 12th of November, which will deal with some of the other aspects which we didn't talk about, like the resource assessment in different types of networks. We have some talks on the other pilot plants and so on. You can contact us via comms@REDAWN, or use Twitter, or via our website here, and we will have a final project event which will go through everything, all of the pilot plants, 3 or 4 I guess will be at that stage, and the various results of the project will be the 9th of February will be the date, likely to be kind of a half-day event then, and likely to be online as well, unless some good news happens with COVID in the meantime. So we have I guess we'll more or less wrap it up now, and if you still have questions, you can pop them in, or else maybe you can email them to us via the email address there, and we can direct them to the speakers. Okay, so thanks very much everyone for your attendance, and thanks to our 2 speakers for giving us some interesting results.